Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a really exciting development in the Swift ecosystem. The open sourcing of Swift Build. It's a game changer, you know? A massive leap forward.
Absolutely, I've been following this closely. So Swift Build, the engine behind Xcode's builds, is now open source. That's huge for the community, right?
Precisely. It means developers now have access to the same powerful, extensible build engine used by Xcode and Apple's internal processes. This isn't just some minor update. This is foundational. It's the engine that transforms code into actual applications, libraries, and tools. Think of it as the heart of the Swift development process.
And it's not just for macOS, is it? The blog post mentions Linux and Windows support too. That's a significant step towards true cross-platform consistency.
Exactly. Cross-platform consistency is key. Before, we had different build systems for different platforms, leading to potential inconsistencies and confusion. Now, with Swift Build, we're moving towards a unified experience, regardless of whether you're building for iOS, macOS, Linux, or Windows. It's a huge win for developers.
I see. So how does this impact Swift Package Manager, SPM?
That's a great question. Currently, SPM has a simpler build engine. This move allows SPM to adopt Swift Build as its underlying engine, creating a unified build process across all platforms. This should be transparent to users, maintaining compatibility with existing packages while paving the way for future improvements and optimizations.
So a unified build system means better performance and more consistent behavior across the board. But what about the existing build system in Xcode? Will that change?
That's a really insightful point. The blog post highlights that the build engine in Xcode is quite sophisticated. By open sourcing Swift Build, Apple is essentially sharing the best practices and technologies used in Xcode with the wider community. This will lead to improvements in both Xcode and SPM's build processes over time.
It sounds like this is a huge undertaking, a massive collaborative effort. How can the community get involved?
The blog post explicitly encourages community involvement. They've made the Swift Build repository available on GitHub, welcoming contributions via pull requests and issue reports. They're also actively soliciting feedback and ideas on the Swift forums. It's a fantastic opportunity to shape the future of Swift's build system.
This is incredibly exciting. It really feels like a new era for Swift development. The potential for improvements in build times, cross-platform compatibility, and overall developer experience is enormous.
Absolutely. This is a significant step forward, and it's all thanks to Apple's commitment to open-source collaboration. It's a win-win for everyone involved. We'll be sure to keep you updated on further developments in this space. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating article about the complexities of pointers and the need for better language specifications in compiler IRs. It's a real head-scratcher, but incredibly important for compiler correctness.
I'm all ears. Pointers are notoriously tricky, even for experienced programmers. What's the core problem this article highlights?
The core issue is that seemingly correct compiler optimizations, when chained together, can lead to incorrect program behavior. The article uses LLVM as an example, but the problem transcends specific compilers. It boils down to the lack of precise semantics in compiler intermediate representations, IRs.
So the optimizations are individually sound, but their combination causes issues? That's counterintuitive.
Precisely. The author illustrates this with a series of 3 optimizations applied to a simple C program. Each optimization seems reasonable in isolation, but the final optimized code exhibits behavior impossible in the original code. It's a subtle bug, but a critical one.
And what's the root cause of this insidious behavior? Is it a flaw in the optimization algorithms themselves?
Not exactly. The problem stems from the imprecise specification of LLVM-IR's semantics. The article argues that compiler IRs need to be treated as proper programming languages with rigorously defined behavior, including undefined behavior, UB, Without this precision, it's impossible to guarantee the correctness of optimizations in isolation.
I see. So the lack of a precise definition allows for these seemingly correct optimizations to interact in unexpected ways, leading to the miscompilation?
Exactly. The article uses a clever example involving pointer integer casts and one past the end pointers to highlight the importance of provenance, the extra information about how a pointer's address was derived. This provenance is crucial for correct alias analysis, but it's often implicitly handled, leading to inconsistencies.
Interesting. So the compiler is essentially making assumptions about the provenance of pointers that aren't explicitly stated in the IR specification? That sounds like a recipe for disaster.
Absolutely. The author argues that the solution is to explicitly define provenance in the IR specification. This would make it clear what information constitutes a value, including provenance and initialization status. This would allow for a more robust UB checking interpreter, making it easier to verify the correctness of optimizations.
But wouldn't explicitly defining provenance add significant complexity to the IR specification and potentially impact compiler performance?
That's a valid concern. The article acknowledges the trade-offs. However, the author argues that the current approach, where provenance is implicitly handled, is even more problematic because it leads to unpredictable miscompilations. A more precise specification, even if more complex, would provide a much more solid foundation for compiler correctness.
So the article advocates for a more formal, mathematically rigorous approach to defining the semantics of compiler IRs?
Not necessarily a fully formal mathematical definition, but a more explicit and comprehensive specification that clearly outlines all aspects of program behavior, including UTB. The author points to projects like MIRI for Rust and Alive for LLVM as examples of efforts in this direction. These tools help in uncovering subtle issues and improving the precision of IR specifications.
It sounds like a significant undertaking, but a necessary one to ensure the reliability of compilers, especially for languages like Rust, C, and C++ that allow for unsafe pointer manipulation.
Absolutely. The article concludes by emphasizing the importance of treating compiler IRs as first-class programming languages, deserving the same level of rigorous specification as normal programming languages. It's a call for a more systematic approach to compiler development, prioritizing correctness over optimization speed in certain critical areas.
It's a compelling argument. Thanks for summarizing this complex topic so clearly. It really highlights the hidden depths of seemingly simple concepts like pointers.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time for another deep dive into the fascinating world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a passionate rant, a well-reasoned argument against sticky headers on websites. It's a surprisingly technical topic.
Right. I saw this article, and the author's intensity is, infectious. He's basically declaring war on sticky headers. What's his main beef?
Primarily, it's about screen real estate. He uses an 11-inch MacBook Air, so vertical space is precious. Those 50 pixels a sticky header occupies could be, 3 lines of valuable content. He also points out that sticky headers mess with his spacebar scrolling, making it jump too far down the page. It's a real productivity killer.
I see. So it's not just an aesthetic thing, it's a usability issue for him. And the solution? A bookmarklet. That's clever.
Exactly. It's brilliantly simple. The code uses query selector all to find all elements with position fixed, which is how sticky headers are implemented, and then removes them. It's a brute force approach, but effective. The code is just a few lines, really elegant.
But wouldn't that remove other important fixed elements, like, say, a persistent navigation bar? Isn't that a potential downside?
That's a valid point. He acknowledges that. He argues that if you need the navigation back, a simple refresh restores it. The trade-off, for him, is worth it. It's a quick fix for a specific problem, not a permanent solution. It's a pragmatic approach.
I get it. It's a temporary solution for a specific user's workflow. It's a powerful demonstration of how a small piece of code can solve a very real problem. It's almost a statement about user agency, taking control of your browsing experience.
Precisely. It's a hack, a quick fix, but it highlights a larger issue. It makes you think about the design choices behind sticky headers and whether they always benefit the user. Maybe there's a better way to implement persistent navigation without sacrificing screen real estate.
Absolutely. It's a conversation starter, really. Thanks for bringing this up. It's a great example of how a simple problem can lead to interesting technical solutions and design discussions.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating GitHub project, BZIP3, a claimed better and stronger spiritual successor to the venerable bzip2 compression algorithm. Pretty exciting stuff, right?
Absolutely. I've always been intrigued by compression algorithms. What makes BZIP3 so special? Is it just faster, or are there more fundamental improvements?
Well, it's not just about speed, although that's a significant part of it. The core innovation lies in its entropy coding. bzip3 uses a novel order -0 context mixing entropy coder, which basically means it's better at predicting the next bit in a data stream. This leads to higher compression ratios.
ORDER zero context mixing. That sounds pretty technical. Can you break that down a bit more for our listeners?
Sure. Think of it like this. Traditional methods look at surrounding data to predict the next bit. ORDER0 means it doesn't rely on that context as much, focusing on statistical properties across the entire dataset. It's a different approach, and apparently a very effective one.
I see. So it's a more global approach to prediction. Interesting. The GitHub page mentions a fast Burrows-Wheeler transform using suffix arrays. What's the significance of that?
The Burrows-Wheeler transform, BWT, is a crucial step in many compression algorithms. It rearranges the data to make it more compressible. bzip3's implementation uses suffix arrays to speed up this process significantly. It's a clever optimization that contributes to the overall performance boost.
So it's a faster and more efficient BWT, combined with this innovative entropy coding. That's a powerful combination. The benchmark results on the GitHub page are pretty impressive, especially the comparison with BZIP2 and XZ.
They are indeed impressive, but we need to be cautious. The benchmarks are based on a specific dataset, a large collection of parallel source code. While this is a relevant test case, it might not be representative of all data types. We should always consider the context of the benchmark.
That's a fair point. Generalizing benchmark results can be misleading. What about the licensing? The GitHub page mentions several different licenses for different components.
Right. The core BZIP3 code is under the LGPL 3.0 license, but some components, like the Burrows-Wheeler transform library, have different licenses. It's important to check the details if you plan to use it in a commercial project. It's a bit of a licensing patchwork, you know?
Definitely something to keep in mind. Overall, though, BZIP3 seems like a significant advancement in compression technology. The combination of improved algorithms and optimized implementations is compelling.
Absolutely. It's a project worth keeping an eye on. The high compression ratios and speed improvements, especially on x64 Linux with Clang 13, are very promising. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of BZIP3. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating project, running Python 3 and Pygame on a Mio A30 handheld console. It's surprisingly straightforward, once you know the tricks.
Wow, a $30 Linux computer with a GPU in your pocket? That's incredible! But how does one even begin to get Python running on such a small device?
That's the beauty of it. The Mio A30, despite its size, packs a punch. It's got a Cortex-A7 processor and a MALI 400 GPU. The key is using Spruce OS, a custom firmware, which provides a much better base than the stock software. It's like upgrading from a rusty bicycle to a sleek sports bike.
So Spruce OS is the foundation. But it doesn't have Python pre-installed, right?
Exactly. We use Debian Bookworm in a CRUD environment. Think of it as a virtual machine, but much more lightweight. We use debootstrap to create a minimal Debian installation tailored for the A30's ARM architecture, including Python 3, Pygame, and essential packages. We carefully select only what we need to keep things lean.
A minimal install is key on such limited hardware, I see. But what about the drivers? Game consoles are notorious for their custom hardware.
That's a great point. The trick is to leverage the drivers already present in Spruce OS. We create a directory, usr local libmyu overrides, and copy the necessary libraries, libgil.so, libgils1_cm.so, libgilsv2.so, libmali.so, libsdel2-2.0.so, and libudev.so from Spruce OS into this directory. Then, we use ldconfig to make sure the CRUT environment can find them. It's a bit of a hack, but it works.
Clever. So we're essentially borrowing the drivers from the host system. But how do you get your Python applications to show up in the Spruce OS interface?
That's where run-inside.sh comes in. This script handles the mounting of necessary directories and safely enters the CRUT environment. Then, a simple shell script in the rom/ports directory launches the Python application using run-inside.sh. It's all about seamless integration.
So you're essentially creating a bridge between the custom firmware and the Debian environment. That's elegant. But were there any snags along the way?
Of course. The biggest issue was screen rotation. Pygame initially displays the screen rotated 90 degrees, while some other libSDL2 builds fix the rotation. They disable GPU acceleration. For now, I'm using Pygame itself to correct the rotation. It's a workaround, but it gets the job done.
A temporary solution, but a functional one. It's amazing what you've accomplished. This opens up a whole new world of possibilities for game development on this tiny device. Housely. I'm particularly excited about the potential for networked multiplayer games.
Absolutely. The author even mentions making networked multiplayer games with his son. The possibilities are endless. And the best part? All the necessary files, the Debian image, the run-inside.sh script, and even a sample Sokoban game are available for download. So, listeners, give it a try.
Definitely worth checking out. Thanks for breaking down this incredible project, anyone. It's inspiring to see what can be done with a little ingenuity and a $30 handheld console.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project, enhancing MIDI hardware using Peril. It's all about pushing the boundaries of what your MIDI keyboard can do. Exciting stuff.
I'm really keen to hear this. So, the core idea is to use Peril to create a software MIDI filter, right? To add features not present in the hardware itself?
Exactly. The author uses an M-Audio Oxygen Pro 61 as an example, but the principles apply broadly. The limitations of even fairly advanced MIDI hardware are addressed by creating a Perl-based MIDI proxy. This proxy intercepts MIDI messages, processes them, and then sends modified or augmented messages on. Ingenious!
So what kind of features are we talking about? Give me the highlights.
Well, there are two main features showcased: a pedal tone effect and a controller bank system. The pedal tone adds a sustained bass note and its fifth to any note played, creating richer harmonies. Think of it as instantly creating a three-note chord from a single key press. It's implemented using clever MIDI message manipulation within the Perl script.
That sounds pretty cool. And the controller banks?
The controller banks let you switch MIDI channels using the pads on the keyboard. Each pad selects a different channel, effectively giving you 16 different banks. This is much more intuitive than the keyboard's built-in bank system. Plus, it extends the functionality beyond the 4 banks the hardware provides.
So it's not just about adding effects, it's about improving the workflow and usability of the hardware too. Clever.
Precisely. And the author even goes further, adding a strum effect to the pedal tone, introducing a slight delay between the notes of the chord. This adds a more expressive, almost strummed quality to the sound. It's a great example of how you can use the asynchronous capabilities of Perl to achieve this kind of timing control.
I'm curious about the implementation details. How does the Perl code actually achieve all this? Is it complex?
The code uses the ART MIDI library, which provides a way to interact with MIDI devices. The core is a MIDI filter class that sets up an event loop and manages MIDI input and output. It uses callbacks to process incoming MIDI events. Each callback can modify the event or create new ones, and they can be chained together to create complex effects. It's elegant, really. The author provides a complete gist with the source code, so you can check it out yourself.
I see. So each MIDI event triggers a callback, and these callbacks can modify the event or create new ones. It's like a pipeline for MIDI data. But what about latency? Doesn't adding this layer of processing introduce significant delay?
That's a great question. The author mentions that previous experiments showed minimal latency, a fraction of a millisecond. This is thanks to the asynchronous nature of the Perl code and the efficient RT-MIDI library. So, it's practically real-time processing.
Interesting. So what are the limitations? Are there any downsides to this approach?
Well, the author points out a potential issue with the bank switching feature. The simple implementation doesn't handle pickup, a feature where control changes only take effect if they exceed the previous value. This could lead to unexpected jumps in control values when switching banks. It's a minor limitation, but something to keep in mind.
Got it. So overall, this is a really impressive project. It shows how you can leverage programming to significantly enhance the capabilities of relatively inexpensive MIDI hardware. It's a testament to the power of open-source tools and creative problem-solving.
Absolutely. It's a fantastic example of how software can extend and improve hardware functionality. And the best part? The code is available, so you can adapt it to your own MIDI controller and create your own custom effects. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Perl and MIDI. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a crucial aspect of home network security: avoiding ISP-provided routers. It's a surprisingly big deal, and the reasons go way beyond just saving a few bucks on rental fees. The potential security risks are significant.
Right. I've always wondered about this. Is it just a matter of default passwords? Or is there more to it? I mean, it seems convenient to just get a router from the ISP.
Oh, it's way more than just default passwords, although that's a huge red flag in itself. Think about it. ISPs prioritize cost and remote management above all else. They want cheap hardware they can easily control remotely. This leaves security as a very low priority.
So they're cutting corners on security to save money? That's pretty alarming. What are some specific examples of this?
Well, there are tons of examples. We've seen ISPs ship routers with known vulnerabilities, sometimes taking months or even years to patch them. There have been instances of backdoors, default passwords, and even cases of ISPs actively collecting data from their customers' networks and sending it back to the ISP. One case involved a router literally infested with cockroaches.
Cockroaches? That's unexpected. But it highlights the lack of quality control, right? What about the spying aspect? Is that really happening?
Absolutely. There's documented evidence of ISPs cooperating with government agencies. But even without that, the potential for backdoors is very real. It's easier for an ISP to monitor traffic if they control the hardware. It's a huge privacy concern.
I see. So it's not just about security flaws, but also about potential misuse of the router's capabilities for surveillance. That's a serious ethical issue.
Exactly. And it's not just about individual incidents. Because ISPs often have a near monopoly in many areas, they have little incentive to improve security. Their customers are essentially captive. They're not motivated to provide high-quality, secure equipment.
That makes perfect sense. So what's the solution? Just buy our own routers?
Yes. Buying your own router gives you complete control over its configuration and firmware updates. You can choose a reputable brand with a strong security track record, and you'll be less of a target for hackers. Plus, you avoid the rental fees, which can add up over time. It's a win-win.
It sounds like a no-brainer, actually. But what about the technical aspects? Are there any specific things we should look for when choosing a router?
That's a great question. We could spend a whole podcast episode on that. But some key things to consider are strong encryption protocols, regular firmware updates, and features like a robust firewall. And of course, make sure to change the default password.
Definitely. This has been incredibly insightful. Thanks for shedding light on this often overlooked security risk.
My pleasure. Remember, your home network security is crucial. Don't let your ISP compromise it. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and have a great day. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the surprisingly rich history of the term mainframe. It's not just a big box, you know? It's a story of evolving meanings and unexpected twists.
I'm intrigued. So what's the core of this mainframe mystery? Did it just magically appear one day?
Not at all. It all started, surprisingly, with the IBM 701 in 1952. Think of it. Individual units, each a frame, working together. The main part? You guessed it. The mainframe. It was literally the main box containing the core components.
So mainframe was initially a descriptive term, referring to a physical component? Fascinating.
Exactly. But here's where it gets really interesting. The meaning morphed. Over time, mainframe started referring not just to the physical box, but also to the CPU itself, the central processing unit. It's a classic case of metonymy, the name of a thing becoming the name of its function.
Wow, that's a significant semantic shift. So it went from a physical description to a functional one? And how did it become the term we know today?
That's the next chapter. The rise of mini-computers and microcomputers in the 70s created a need to distinguish between different sizes of computers. Mainframe stepped in to fill that gap, becoming a category of its own, representing large, powerful machines used for massive data processing.
So it went from a part to a type of computer? That's a dramatic evolution. Did IBM always embrace the mainframe label?
Not initially. Initially, IBM preferred terms like general-purpose computer. It wasn't until the mid-1980s that they fully embraced mainframe in their marketing. It's almost ironic, considering their close association with the term today.
I see. That's a really interesting point. So the term's popularity wasn't just driven by technical advancements, but also by marketing and the need for clear categorization in the industry?
Precisely. The rise of microcomputer and minicomputer created a linguistic need for a counterpart. Mainframe fit perfectly, and it also helped to distinguish IBM and other large computer manufacturers. It's a compelling example of how language evolves to meet the needs of a changing technological landscape.
Absolutely. And what about the public's perception? When did the average person start using mainframe?
The public's awareness grew significantly in the 1980s, mirroring its increased use in dictionaries, encyclopedias, and newspapers. But interestingly, its peak popularity in the media actually came later than the peak of minicomputers and microcomputers.
That's counterintuitive, considering mainframes came first. So the term's popularity lagged behind the technology itself?
Exactly. It highlights the complex interplay between technological development and linguistic adoption. The term mainframe only truly took off when the public needed a way to distinguish large computers from the newly popular smaller ones. It's a fascinating case study in the evolution of technological terminology.
This has been a truly enlightening discussion. It shows how a seemingly simple term can have such a complex and multifaceted history. Thanks for shedding light on this.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you enjoyed this deep dive into the surprisingly rich history of the word mainframe. Until next time, goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of YouTube audio quality. Specifically, we'll be exploring a detailed analysis of how YouTube's audio codecs and bitrates affect the final sound you hear. Get ready for a technical deep dive.
Sounds exciting. I've always wondered about the quality differences between YouTube videos. What's the core finding of this analysis? Is Opus really better than AAC?
Well, it's not quite that simple. The study compared YouTube's output to source audio files, looking at both AAC and Opus codecs at various bitrates and sample rates. The author used some really clever techniques, like cross-correlation, to precisely align the waveforms for comparison. It's a very rigorous approach.
Cross-correlation? Could you explain that a bit more? I'm not sure I fully grasped that.
Sure. Imagine you have two almost identical sound waves. but one is slightly shifted in time. Cross-correlation is a mathematical method that finds the best overlap between these waves, revealing the exact time difference. This is crucial for comparing the source and YouTube versions accurately. It's like finding the perfect alignment of two puzzle pieces.
I see. Interesting. So what did the alignment reveal about the audio quality?
The results were mixed. In one case, using the Opus codec at 48 kHz, the YouTube version showed a significant difference from the source, about 20 decibels below the original signal level. That's a pretty substantial difference, equivalent to around 10% distortion. Ouch!
Wow, 10% distortion is a lot. But what about the other codec, AAC?
The AAC comparison, at 44.1 kHz, showed a smaller difference, around -30 to -35 decibels, which is equivalent to about 3% distortion. A definite improvement, but still not perfect. The key takeaway is that both codecs suffered from high-frequency roll-off.
High-frequency roll-off? What does that mean?
It means YouTube's processing essentially cuts off the highest frequencies in the audio. In the Opus example, it was around 20 kHz. In the AAC example, it was even lower, around 16 kHz. This loss of high frequencies impacts the overall detail and clarity of the sound. It's like losing the fine brushstrokes in a painting.
So neither codec is perfect on YouTube. Is there a clear winner?
Based on this study, the AAC version at 44.1 kHz showed slightly better fidelity than the Opus version at 48 kHz, but both suffered from high-frequency loss. It's important to remember that this is just one study, and more research would be needed to draw definitive conclusions. The author also points out that sample rate conversion could be a factor.
Right, that makes sense. So what about the BBC iPlayer comparison? How did that fare?
The BBC iPlayer comparison using a 320 kilobits per second AAC stream showed significantly better results than YouTube. The error level was around -40 decibels, much lower than either YouTube example. This highlights the impact of bitrate on audio quality. It's a stark contrast.
So higher bitrates generally mean better quality, huh? That's not surprising, but it's good to see it confirmed. What's the overall takeaway from all this?
The main takeaway is that YouTube's audio compression, while functional, does introduce noticeable artifacts, particularly in the high frequencies. The choice of codec seems less important than the bitrate, and the potential for sample rate conversion during the process. It's a complex issue, with no easy answers.
It certainly is. Thanks for breaking down this complex analysis for us. This was a really insightful discussion.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating project, visualizing the entire world's books in ISBN space. It's mind-blowing, really. Imagine a visual representation of every book ever published with an ISBN.
Whoa, that's ambitious. 100 million books, you say? How on earth do you even begin to visualize something that massive?
That's the genius of it. The key is the ISBN itself. Each ISBN is a 13-digit number. And while it seems like a simple identifier, it holds the key to this incredible visualization. The first few digits represent geographic regions and publishers, creating a hierarchical structure.
I see. So you're not just plotting random points. You're using the inherent structure within the ISBN to organize the data spatially?
Exactly. But simply mapping ISBNs linearly wouldn't work. It would be incredibly stretched and difficult to interpret. So the author employed a space-filling curve, specifically a custom bookshelf curve, to project this one-dimensional ISBN space into a two-dimensional image.
A bookshelf curve? Intriguing. What makes it different from other space-filling curves like the Hilbert curve?
The Hilbert curve, while effective, introduces artificial structures that aren't actually present in the data. The bookshelf curve avoids this, providing a more accurate and visually appealing representation. It's based on a recursive decimal layering, creating a visually intuitive structure resembling, you guessed it, bookshelves.
Clever. So how does the visualization actually work? Is it just a giant image?
It's much more sophisticated than that. The visualization is tiled. Each tile represents a specific ISBN prefix and contains data about the books within that prefix. The data is stored efficiently, using color channels to represent things like average publication year and the percentage of books that exist digitally.
And the shaders, what role do they play?
The shaders are where the magic really happens. They allow for dynamic manipulation of the data on the GPU. You can change color schemes, apply filters, and even combine multiple datasets in real time. The author provides examples of GLSL code that allows for incredible flexibility.
That's impressive. So it's not just a static visualization, it's interactive and highly customizable. What about performance? Handling that much data must be a challenge.
It was. The author faced significant performance hurdles, especially with text rendering. Initially, they tried various methods, including web workers, but ultimately found that optimizing CSS and reducing DOM elements was the most effective solution. The use of React3.js Fiber for rendering the hierarchical tree structure of ISBN prefixes was also crucial.
So it's a combination of clever data structures, efficient storage, powerful shaders, and careful performance optimization. It sounds like a truly remarkable achievement. What about the flight path feature?
Oh, the flight path. That's a whole other story. The author even had to enlist the help of a friend to solve the complex mathematical problem of generating smooth and visually appealing flight paths through this massive ISBN space. It involved creating a custom blub space transformation, which, let's just say it was quite involved.
Sounds like a fascinating mathematical challenge. So, in conclusion, this project is a testament to the power of creative data visualization. It's not just about presenting data. It's about creating a truly immersive and interactive experience.
Absolutely. And the best part? The entire project is open source. You can explore the code, contribute, and even create your own visualizations. It's a truly inspiring example of what's possible when you combine creativity, technical skill, and a healthy dose of perseverance. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a revolutionary advancement in metal 3D printing, Meltio's LMD technology. It's a game changer, folks.
A game changer? I'm intrigued. What makes this LMD process so different from existing methods?
Well, unlike traditional powder-based methods like selective laser melting, SLM, LMD uses metal wire as its feedstock. Think of it. No more messy powders, no more explosion risks, no more respiratory hazards for workers. It's a significantly safer process.
So just wire? How does that even work? I'm picturing a giant spool of wire and a really hot laser.
Exactly. Meltio uses 3 to 6 low-power diode lasers to create a melt pool. It's like a constantly moving, yet stationary contact patch. A bit like the contact patch on a tire. Always in motion, but always in the same relative position. The lasers melt the wire, and layer by layer, it builds the 3D object. Incredibly efficient.
And the waste? That's the big deal, right? Powder-based methods are notoriously wasteful.
Precisely. With LMD, there's virtually no waste. Only the wire needed for the part is consumed. No more mountains of powder to clean up. Just spools of wire, easy to handle and store. A massive improvement in terms of sustainability.
That's impressive. What materials can it handle?
It's incredibly versatile. Stainless steel, titanium, aluminum, copper, and various alloys are all fair game. And here's a really cool part. You can even use 2 different wires simultaneously. Imagine printing a part with tool steel on the outside for durability and mild steel inside to reduce costs.
That's brilliant. So you could create parts with customized material properties, layer by layer?
Exactly. Or you could even combine corrosion-resistant and regular metals for parts exposed to harsh environments. The possibilities are endless. And it doesn't stop there. LMD can also print onto or around existing parts, opening up amazing repair possibilities. Think about repairing damaged engine components, or even aerospace parts. This is huge.
Wow, this is truly revolutionary. But what about precision? Is it as accurate as SLM?
Well, it might not match SLM's precision out of the box, but the parts can be conventionally machined afterwards for higher precision if needed, and Meltio argues that this is still less wasteful than machining a whole billet. A smart approach.
That's a good point. So is this technology readily available? Do I need to buy a whole new machine?
No, that's another great aspect. Meltio's technology can be integrated into existing robot arms, or CNC machines. It's not just about buying a new machine. It's about upgrading your existing equipment. Smart, cost-effective, and sustainable.
This is all incredibly exciting. It seems like LMD addresses many of the limitations of current metal 3D printing techniques. A truly significant advancement.
Absolutely. From safety and sustainability to versatility and cost-effectiveness, LMD is poised to reshape the metal 3D printing landscape. It's a technology that deserves a lot of attention, and we're excited to see what the future holds. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of LMD. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating article from LWN.net about creating a keyboard-driven desktop. It's all about minimizing mouse usage for productivity and ergonomics, a topic near and dear to many of us, I'm sure. Let's get started.
Absolutely. I'm eager to hear this. The title alone grabbed my attention. What are some of the key tools and techniques discussed?
Well, the article explores a range of solutions. First up is Paper WM, a scrollable tiling window manager for GNOME. It addresses the limitations of traditional tiling managers, especially on smaller screens. By introducing a virtual viewport, imagine having a workspace larger than your screen, scrolling through windows with keyboard shortcuts. Pretty slick, right?
That sounds incredibly efficient. No more wrestling with window resizing. But what about other applications? How does this approach extend beyond window management?
Exactly. The author also highlights Firefox bookmark keywords, a surprisingly powerful yet often overlooked feature. By assigning keywords to frequently visited sites, you can access them instantly from the address bar. Think of it as a supercharged bookmark system. Genius!
I see. So, less clicking, more typing. But what about web browsing itself? Surely that's still mouse-heavy?
Not with Vimium, a browser extension that brings Vim-like keyboard shortcuts to Firefox, Chrome, and Edge. It's modal, meaning navigation is done with alphabetic keys, similar to Vim. You can open links, select text, even manage your history and bookmarks, all without touching the mouse. It's a game changer.
Wow, that sounds intense. I'm a bit intimidated by Vim, but this sounds like a more accessible way to get similar benefits. What about email? Is there a keyboard-centric solution for that?
Absolutely. The article mentions AERC, a terminal-based email client with Vim-like key bindings, combined with Quake Terminal, a GNOME extension that provides a drop-down terminal. You can quickly access and dismiss your email without disrupting your workflow. It's all about seamless integration.
Interesting. So it's not just about individual applications, but also about how they work together. What about the author's experience with Emacs?
Ah, yes. The author, being a longtime Vim user, initially struggled with Emacs's default key bindings, but they cleverly integrated Evil, an extensible VI layer for Emacs, to retain their muscle memory. They even went further, hiding the menu and toolbar to force themselves to use shortcuts. A true testament to commitment.
That's dedication. Impressive. But what about situations where a mouse is still necessary? Does the article address that?
Yes. The author acknowledges that some tasks, like image editing, are still better suited for a mouse. The goal isn't complete mouse elimination, but rather a significant reduction in its use. They also mention Input Remapper, a tool for remapping keyboard and mouse inputs, allowing for highly customized key bindings. It's all about finding the right balance.
So it's a pragmatic approach, not a dogmatic one. A very insightful article. Thanks for summarizing it for us.
My pleasure. It's been a fascinating journey exploring these tools and techniques. Remember to check out the LWN.net article for more details and links to the projects discussed. And that's all the time we have for today. Thanks for tuning in to Tech Bytes and News. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating and frankly alarming story about the disappearance of thousands of datasets from data.gov. It's a real-world data loss crisis, folks.
Whoa, that sounds intense. So what's the core issue here? Is data.gov just vanishing?
Not exactly vanishing, but more like being systematically pruned. The article highlights a significant drop in the number of datasets on data.gov, particularly noticeable after the Trump administration took office. We're talking thousands of datasets, potentially containing crucial information.
Thousands? That's a huge amount of data. What kind of data are we talking about?
A wide range, actually. The article points to disproportionate losses from agencies like the Department of Energy, NOAA, the Department of the Interior, NASA, and the EPA. Think climate research, environmental data, potentially even research on marginalized communities. All potentially lost.
Oh my gosh, that's incredibly concerning. Is it definitively malicious data deletion? Or could there be other explanations?
That's the million-dollar question. And the article emphasizes the complexity of the situation. While some deletions are undoubtedly intentional, remember, the Trump administration issued an executive order targeting DEI initiatives. Some might be due to routine administrative changes, website redesigns, or simple link rot. It's a messy mix.
So it's not a simple case of bad guys deleting data? There's a lot of nuance here.
Exactly. Researchers like Jack Cushman at Harvard are working to archive the data, creating a snapshot of what was there before it disappeared. But even that's a monumental task, because data.gov is an aggregator. It doesn't always host the data itself. Sometimes it just links to other government websites.
That makes archiving even harder, right? It's like trying to find a needle in a digital haystack, except the haystack is constantly shifting.
Precisely. Mark Phillips from the University of North Texas, working on the end-of-term web archive, points out the challenges of archiving data from an aggregator, or crawling terabytes of data. But even that might not capture everything.
So what's the takeaway here? Is all hope lost? Is all this data gone forever?
Not necessarily lost forever, but definitely a wake-up call. The article highlights the fragility of digital government data and the urgent need for better archiving practices. The researchers are working hard, but the scale of the problem is immense. The fact that the Trump administration actively targeted certain types of data makes the situation even more critical.
It's a chilling reminder of how easily information can be lost or manipulated in the digital age. And the lack of clear regulations regarding data preservation is a huge problem.
Absolutely. The article emphasizes that the government information crisis is bigger than you think. The shift from physical archives to digital ones has introduced new vulnerabilities, and we need to address them before more irreplaceable data vanishes.
This is a really important discussion, and it highlights the need for better data governance and preservation strategies. Thanks for bringing this to our attention.
My pleasure. And thank you for listening to Tech Bytes and News. We hope you found this discussion informative and, dare I say, slightly terrifying. Until next time, stay informed and stay safe in the digital world. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating development in refrigeration technology, a new type of fridge that promises to be far more efficient and eco-friendly. Exciting stuff.
Absolutely, I've been following this research. So what's the core innovation here?
It's all about thermogalvanic cells. Think of it as a chemical battery, but instead of producing electricity, it uses electricity to pump heat out. Previously, these cells were incredibly inefficient, only managing a 0.1 degrees Celsius drop.
0.1 degrees Celsius? That's barely noticeable.
Exactly. But this new research, published in Joule, has made a huge leap. They've managed a 1.42 degrees Celsius drop using a clever electrolyte solution.
A 1.42 degrees Celsius improvement is significant, isn't it? What's the secret sauce?
The key is the electrolyte. They used a chlorine-containing iron salt and a solution of nitriles, nitrogen and carbon-based compounds. These substances facilitate the movement of charged iron atoms, which absorb and release heat depending on their electron state. It's all about cleverly managing the electron transfer to control heat flow.
So it's a chemical reaction driven by electricity, reversing the usual process where heat drives electricity generation?
Precisely. It's a really elegant solution, and the researchers are pretty optimistic about scaling this up. They believe it could lead to significantly more efficient refrigerators.
I see. But isn't there a catch? A 1.42 degrees Celsius improvement is still pretty modest for a refrigerator, right?
You're right to be cautious. The researchers themselves acknowledge that there's still work to be done. They need to improve the system's scalability and long-term stability. It's a prototype, after all.
Right. It's a proof of concept, showing the potential. But commercial viability requires more than just a lab demonstration.
Absolutely. They're working on improving the performance, developing different prototypes, and seeking collaborations with companies to bring this technology to market. It's a marathon, not a sprint.
It's incredibly promising, though. More efficient fridges mean less energy consumption and a smaller carbon footprint. That's a win-win.
Exactly. And it's not just about energy savings. This technology could also lead to quieter, more reliable refrigerators. Think about the potential for miniaturization too. This is a game changer.
I agree. This is definitely something to keep an eye on. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating job posting. Office Manager at MindsDB, a rapidly growing AI startup in San Francisco. Sounds exciting, right?
Absolutely. MindsDB, huh? I've heard of them. They're big in the AI space, right? So what's the gist of this office manager role?
Yeah, they're a major player. This isn't just any office management gig. We're talking about a multifaceted role, a real powerhouse position in a dynamic startup environment. They need someone who can handle everything from facilities management to event coordination.
Wow, that's a broad scope. So let's break it down. What are the key responsibilities?
Right. The job description is pretty comprehensive. On the office management side, we're talking full spectrum responsibility. Overseeing facilities, managing vendors, handling supplies, ensuring security, and even managing the office kitchen and catering. It's a lot.
That's intense. And what about the event coordination aspect?
That's a significant part of the job, too. They're looking for someone to collaborate with the developer relations and business development teams to plan and execute both internal and external events. Think everything from logistics to safety protocols and ensuring MindsDB's code of conduct is followed.
So basically, this person is the glue that holds the office together. They need to be incredibly organized, a great communicator, and a real problem solver.
Exactly. The requirements section highlights this perfectly. They want someone with at least 3 years of experience in office management and event coordination, strong organizational skills, excellent communication, and a deep understanding of safety and security protocols. A pretty demanding role.
I see. And the compensation? Is it competitive?
Oh, absolutely. They list a salary range of $75,000 to $95,000 USD, plus a whole host of benefits. Flexible working hours, competitive insurance, 401k matching, unlimited PTO, a remote setup budget, and even a well-being budget. It sounds pretty sweet.
It does sound pretty good. But I wonder if the unlimited PTO is actually unlimited. Or if there's some kind of unspoken expectation. You know how that can be sometimes.
That's a valid point. It's always wise to clarify those things during the interview process. But overall, this seems like a fantastic opportunity for the right person. Someone who thrives in a fast-paced environment, loves a challenge, and has a passion for creating a positive and productive workspace.
Definitely. It seems like a great fit for someone with a strong background in both office management and event planning, and who's comfortable navigating the complexities of a tech startup. A true all-rounder.
Precisely. And don't forget the perks. Lunch provided daily, an internet budget, a commuter budget, and even a learning and development budget. MindsDB seems to really value its employees.
It certainly seems that way. Well, that's a pretty comprehensive look at the MindsDB office manager position. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating story from Wired about the chaotic aftermath of an email at Elon Musk's DOG initiative. It's a real roller coaster.
Oh boy, Elon Musk and chaos. Sounds like a perfect match. What's the gist?
Basically, staff at DOG, formerly the U.S. Digital Service, received a fork-in-the-road email offering deferred resignations. Think of it as a highly pressured buyout offer. The deadline's looming, and the new HR chief, Stephanie Holmes, isn't exactly providing clarity.
A deferred resignation? That sounds ominous. What's the catch?
That's the million-dollar question. The email, similar to one Musk sent Twitter employees, suggests that those who don't resign might face job cuts later. It's all very vague, and employees are understandably freaking out.
So they had a meeting with this new HR person, and she didn't offer much help?
Exactly. Dozens of employees bombarded Holmes with questions about everything from project futures to return to office mandates. Her responses? Mostly, I don't know. Or, the offer is lawful. Not exactly reassuring.
Seriously? That's incredibly unprofessional. I mean, you'd think an HR representative would have some answers, especially with such a time-sensitive situation.
Tell me about it. One employee even pointed out the potential for email spoofing. Someone could theoretically send a resignation email on behalf of a staffer. Holmes's response? I don't know. It's a complete mess.
This whole thing sounds like a recipe for disaster. And the fact that this is happening within a government agency makes it even more concerning. What's the background on DOGE?
Right. DOGE, or the Department of Government Efficiency, was created by President Trump and headed by Musk. It's essentially a restructuring of the U.S. digital service, aimed at cutting government spending. It's also facing lawsuits challenging its legitimacy as a federal agency.
So, a controversial agency, a vague resignation offer, and an unhelpful HR representative. This is a perfect storm of workplace anxiety. What about this Holmes woman? What's her background?
Apparently, she's an employment attorney and consultant, known for her non-woke and Christian DEI approach. This is a pretty significant detail, considering the context. It raises questions about the kind of culture Musk is trying to cultivate.
Wow, that adds another layer of complexity. So the employees are left in the dark, facing a potentially huge decision with minimal information and a deadline fast approaching. This is a really troubling situation.
Precisely. The article also mentions that senior leaders at the Office of Personnel Management were told to prepare for up to 70% workforce cuts. The uncertainty extends far beyond just DOGE.
This whole thing is a disaster waiting to happen. Thanks for breaking down this wild story for us. It's certainly a cautionary tale about the potential downsides of opaque leadership and poor communication.
Absolutely. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a truly mind-blowing discovery, a completely new class of life found within the human body. Prepare to be amazed.
Whoa, a new class of life? That's incredible. Is this some kind of extremophile, thriving in an unexpected environment? Or something even more bizarre?
It's even more fascinating than that. These organisms, dubbed obelisks, were initially mistaken for viruses. But they're unlike anything we've ever seen before.
Unlike any known virus? What makes them so different? Do they have DNA or RNA?
That's the kicker. They don't seem to have any detectable sequence similarities to existing biological agents. They're structurally unique too. While they share some superficial similarities with viruses, the differences are profound. They're not just a new strain. They represent a whole new class.
30,000 different obelisks have been identified, right? That's a huge number. What's the significance of that?
Exactly. The sheer diversity suggests they might be colonists of various microbiomes. They were found in about 10% of the human microbiomes examined. This is a significant finding, suggesting a previously unknown level of biological complexity within us.
So if they're not viruses, what are they? Are they bacteria? Some kind of archaea?
That's what researchers are trying to figure out. They seem to code for a new protein class, which they've named oblins. This protein coding ability sets them apart from other known RNA loops, like viroids. It's a huge mystery.
Oblins. I like the sound of that. But if they code for proteins, do they have the machinery to build protein shells like other RNA viruses, like, say, COVID-19?
No. That's another key difference. They lack the genetic makeup for those protein shells, which is crucial for viruses to survive outside their host cells. It's a fascinating puzzle.
So it's a completely new branch on the tree of life? This changes everything. What are the implications of this discovery?
It's huge. It completely reshapes our understanding of the human microbiome and the diversity of life on Earth. The research is still in its early stages though. It's a preprint on bioRxiv, so further peer review is needed to confirm these findings. But the potential implications are enormous.
Absolutely. This could revolutionize medicine, our understanding of disease, and even our understanding of evolution. It's a game changer, no doubt.
Precisely. This is a monumental discovery, and it's just the beginning. The research is ongoing, and we'll be sure to keep you updated as we learn more. Thanks for tuning in to Tech Bytes and News. We'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into Miecha AI, a fascinating new tool promising to boost productivity tenfold. It's essentially an AI intern living in your browser. Exciting, right?
Tenfold productivity? That's a bold claim. Tell me more. How does it actually work?
It's all about leveraging the power of your browser. Miecha uses its own custom agentic framework, powered by OpenAI GPT models and clever scraping algorithms. Think of it as a sophisticated web automation tool, but controlled entirely through natural language prompts. Imagine the possibilities.
So instead of writing complex scripts, you just tell Miecha what to do? Like, scrape this website for product prices?
Exactly. It can navigate websites, extract data, and even output that data in various formats like JSON, CSV, or Markdown. It's incredibly versatile. They even have examples of lead generation from platforms like Google Maps and LinkedIn.
That's impressive. But how does it handle complex tasks? Does it have any limitations?
They mention a built-in memory and file system for handling long-term tasks, which suggests it can manage multi-step processes. However, the details on the limitations are scarce. It's still early days, and they're planning to open-source parts of the SDK, including their semantic analysis algorithm.
Open sourcing parts of it is a smart move. It fosters community involvement and transparency. But, I'm curious about the team behind Miecha. Who are these productivity ninjas?
The core team consists of Jared Wright, a software engineer with experience at the New York Times and Shapeways, and Art Abra, a solopreneur with a passion for tech and UX. A pretty impressive duo.
It sounds like a promising project. But I wonder about the long-term sustainability. They mentioned being 100% bootstrapped. How will they manage scaling and ongoing development?
That's a valid concern. Bootstrapping can be challenging, especially for a project with such ambitious goals. Their success will likely depend on user adoption and potentially securing funding down the line. But their focus on building practical tools and open sourcing parts of their technology suggests a commitment to long-term growth.
I see. It's definitely a project to keep an eye on. The potential for increased productivity is significant. Thanks for breaking it down.
My pleasure. Miecha AI is a really interesting development in the world of AI-powered automation. Remember to check out their website for more details and stay tuned for their open source release. Thanks for tuning in to Tech Bytes and News. Have a great day, everyone.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a truly alarming development: the alleged alteration of CDC data to comply with the Trump administration executive order. It's a story that raises serious questions about scientific integrity and public health. This is a big deal.
Absolutely. The article in The Atlantic paints a disturbing picture. It seems scientists were frantically downloading data before it vanished or was altered, right? That's incredibly concerning.
Precisely. The article highlights the disappearance of key datasets, including those from the Youth Risk Behavior Surveillance System, parts of the Agency for Toxic Substances and Disease Registry's indices, and even the HIV data landing page. The Atlas Plus tool, a treasure trove of nearly 20 years of data, is also down. It's not just inconvenient, it's a potential catastrophe.
And the reason behind this? The administration is reportedly targeting keywords like gender, transgender, non-binary, and even pronouns, replacing them with sex, or removing them entirely. This isn't just about semantics, it's about erasing vital demographic information.
Exactly. These terms aren't just buzzwords, they're crucial for understanding how diseases affect different communities. The article mentions a document suggesting the government intends to replace these keywords, even if it means potentially altering the scientific integrity of the data. That's a terrifying thought.
I see. It's a blatant disregard for scientific accuracy. The article quotes epidemiologists who emphasize that this data is essential for targeting health interventions. How can we effectively address health disparities if we're deliberately obscuring the data that reveals them?
That's the million-dollar question. The article gives examples. Gay men having higher rates of STIs but lower rates of obesity, transgender women having higher rates of HIV grooming. Removing this data makes it impossible to tailor effective public health responses. It's like trying to navigate with a ripped map.
And the implications extend beyond specific diseases. The article points out that this could affect funding allocation for public health initiatives. If data showing a health issue affecting a specific community is removed, it could be used as justification to cut funding for that community. It's a vicious cycle.
It's a deliberate undermining of public health, plain and simple. The article mentions researchers scrambling to archive the data, fearing retaliation for speaking out. This is a chilling attack on scientific freedom and public health. The potential consequences are enormous.
Absolutely. The article also highlights the difficulty of reconstructing the data, even if it's possible. It's a monumental task, and it raises concerns about future data sharing and collection. This isn't just about the past, it's about the future of public health research.
And that's the truly frightening part. The article concludes by emphasizing that altering this data creates a skewed, unreliable portrait of reality. It's a deliberate distortion of truth, with potentially devastating consequences. We need to be vigilant and demand accountability.
Completely agree. This is a critical issue that demands our attention. Thanks for bringing this to light. This is a wake-up call.
You're welcome. And to our listeners, thank you for tuning in to Tech Bytes and News. We hope this discussion has been informative and a little bit unsettling. Remember to stay informed and engaged. Goodbye for now.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating piece of legislation. Senate Bill 321 from the 119th Congress. It's all about AI and its implications for U.S.-China relations. Intriguing, right?
Absolutely. So what's the gist of this bill? I'm particularly interested in the technical aspects. How does it aim to control the flow of AI technology?
Essentially, S-321 aims to prevent U.S. citizens from contributing to the advancement of AI capabilities within China. It's a pretty significant move, focusing on restricting the transfer of knowledge and expertise. Think of it as a high-tech export control, but specifically targeted at AI.
I see. But how would such a bill even be enforced? It seems incredibly difficult to monitor and regulate the movement of knowledge and expertise, especially in the digital age.
That's a great point, and a major challenge. The bill doesn't lay out the specifics of enforcement yet, but it's likely to involve a combination of things. We might see increased scrutiny of research collaborations, stricter regulations on data sharing, and potentially even criminal penalties for violations. It's a complex issue with many legal and practical hurdles.
It makes you wonder about the unintended consequences. Could this stifle innovation within the U.S. itself? By limiting collaboration, are we potentially hindering our own progress in AI?
That's a valid concern. There's a definite risk of slowing down U.S. AI development if the bill is too broadly applied. The challenge is to strike a balance between national security concerns and the need to foster innovation. It's a delicate balancing act.
Exactly. And what about the definition of advancing AI capabilities? That seems like a pretty broad term. How do you define that precisely enough to create effective legislation? It could be interpreted in many different ways.
That's a crucial detail that's not yet fully defined in the bill. The lack of specificity is a potential weakness. The interpretation of this phrase will be key to how the bill is implemented and its ultimate impact. It could lead to legal challenges and debates down the line.
So this bill is still in its early stages, having only been read twice and referred to the Senate Judiciary Committee on January 29, 2025. There's a long way to go before it becomes law, if it ever does.
Precisely. It's crucial to follow its progress through the committee process and subsequent debates. The details of enforcement and the definition of key terms will be critical to understanding its real-world impact. It's a bill that deserves close attention from anyone interested in AI and geopolitics.
Absolutely. This is a really complex issue with far-reaching implications, and the debate surrounding S.321 is only just beginning. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bites and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating discovery from the University of Liverpool: the detection of collagen in a dinosaur fossil. Incredible, right?
Absolutely. Collagen in a dinosaur fossil? I thought that kind of organic material wouldn't survive fossilization. This is a game changer, isn't it?
Exactly. For years, the prevailing belief was that fossilization destroyed all organic molecules. But this study, published in Analytical Chemistry, completely flips that script. They found collagen remnants in an Edmontosaurus hip bone, a duck-billed dinosaur, if you're not familiar.
An Edmontosaurus? Wow. And how did they manage to detect such ancient collagen? What kind of techniques were involved?
Cutting-edge stuff! They used a combination of advanced mass spectrometry, protein sequencing, and imaging techniques. The researchers even identified hydroxyproline, a specific amino acid found in collagen, confirming its presence. It wasn't just a trace amount either. They found significant remnants.
Amazing. So what are the implications of this discovery? Beyond just proving the existence of ancient collagen, I mean.
Oh, the implications are huge. First, it completely refutes the idea that any organic material found in fossils is just contaminations. Second, it suggests that we should re-examine existing microscopy images of fossil bones. There might be a treasure trove of collagen waiting to be discovered.
A treasure trove. That's a fantastic point. It's like they've opened up a whole new field of research just by confirming this one thing. I'm curious, though, how did they manage to preserve the sample so well? Was it a particularly well-preserved fossil?
Yes, it was exceptionally well preserved. A 22-kilogram sacrum from the Hell Creek Formation in South Dakota. University of Liverpool's collection is quite something, you know. But it wasn't just luck. The advanced techniques they used were crucial in extracting and analyzing the collagen.
I see. So this collaboration involved multiple universities and research groups, right? The University of Liverpool's Mass Spectrometry Research Group, their Materials Innovation Factory, the Center for Proteome Research, and even UCLA.
Precisely. A true interdisciplinary effort. UCLA used tandem mass spectrometry to confirm the hydroxyproline, which was a critical piece of the puzzle. The collaboration really highlights the power of combining different expertise and resources.
This is truly groundbreaking. It opens up so many possibilities for understanding dinosaur biology, evolution, and even the fossilization process itself. It's almost like we're getting a glimpse into the biochemistry of extinct creatures. Incredible!
Exactly. Professor Steve Taylor, chair of the Mass Spectrometry Research Group at Liverpool, put it perfectly. This research could unlock new insights into dinosaurs, for example, revealing connections between dinosaur species that remain unknown. It's a new era for paleontology, no doubt.
I'm so excited to see what comes next. This is a huge leap forward in our understanding of the past. Thanks for breaking this down for us.
My pleasure. And that's all the time we have for today's Tech Bites and News. Thanks for listening, and we'll catch you next time with more exciting discoveries. Goodbye.
Bye-bye.
Welcome to Tech Bites and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating development from the University of Waterloo, a smart fabric that heats up in sunlight. It's pretty amazing, isn't it?
Absolutely. 30 degrees Celsius in just 10 minutes? That's a significant temperature increase. What's the secret sauce? Nanoparticles, right?
Exactly. They've embedded conductive polymer nanoparticles into the fabric's fibers. These nanoparticles are activated by sunlight, absorbing the energy and converting it into heat. It's a completely passive system. No batteries or external power source needed. Ingenious.
So no more bulky, battery-powered heated clothing? This sounds like a game changer for outdoor activities in cold weather. What about safety concerns with traditional heated clothing?
Yeah. Traditional heated clothing often uses metals or ceramics, which can pose safety risks. This new fabric eliminates those risks entirely. Plus, it's environmentally friendly, which is a huge plus. It's a win-win.
I see. Interesting. But how durable is this fabric? Can it withstand, regular wear and tear? And washing?
That's a great question. The researchers designed it to be incredibly durable. It can stretch up to 5 times its original size and survive at least 24 washes without losing its functionality or appearance. Impressive, right?
Very. And the color-changing aspect, is that just a cool feature, or does it serve a purpose?
It's both. It's a built-in temperature monitor. The color change is reversible, providing visual feedback on the fabric's temperature. It's a clever way to ensure the wearer's safety and comfort. Smart.
So what are the next steps for this technology? Is it ready for mass production?
Not quite yet. The team is currently working on finding more cost-effective alternatives to some of the materials, specifically polydopamine, to make it more accessible. They're also focusing on scaling up the production process. But the potential applications are huge.
Indeed. I can see this being used in cold weather rescue situations, or even in pet clothing to keep animals warm. It's a really exciting development. What about the study itself? Where can our listeners find more information?
The study was published in the Journal of Advanced Composites and Hybrid Materials. We'll include a link in the show notes, of course, but overall, this smart fabric is a remarkable achievement. It's a testament to the innovative work being done at the University of Waterloo.
Completely agree. A truly exciting advancement with a lot of potential. Thanks for sharing this with us.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you enjoyed this update on the latest in technological advancements. Have a great day, and we'll see you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into AMD's guide on running DeepSeek R1 distilled reasoning models. It's amazing how far this technology has come.
Yeah, I'm really excited about this. These DeepSeek R1 models use chain-of-thought reasoning, right? That's a big deal for complex tasks.
Exactly. Instead of spitting out an immediate answer, they meticulously generate a thinking sequence, processing tons of tokens. Think of it like a human carefully considering different angles before forming an opinion. It takes longer, but the results are often far more accurate, especially in scientific research or complex mathematical problems.
So what kind of hardware support are we talking about here? I'm guessing it's not just any old CPU.
You're right. AMD supports various DeepSeek R1 distillations across its Ryzen AI processors and Radeon GPUs. The larger the processor, like the Ryzen AI Max Plus 395 series, the bigger the models it can handle, such as QN32B. Mid-range Ryzen AI processors might manage QN14B or Llama 14B. Similarly, high-end Radeon cards like the RX 7900 XTX can run QN32B, but smaller models are better suited for lower-tier cards. And, importantly, AMD recommends Q4KM quantization to optimize memory usage.
Q4KM quantization? Could you explain that a bit more?
Sure. It's a way to reduce the size of the model, making it more efficient. Think of it like compressing a large file. You lose some detail, but the file becomes much smaller and easier to manage. This is crucial for running these large models on less powerful hardware.
I see. So how do you actually get this up and running? Is it complicated?
Not at all. It's surprisingly straightforward. First, you need the Adrenalin 25.1.1 driver or newer, and LM Studio 0.3.8 or later. Then, you use LM Studio's Discover tab to select your model, ensure Q4KM quantization, and adjust GPU offload layers based on your system's capabilities. After that, it's just a matter of loading the model and interacting with it.
That sounds pretty user-friendly. But what about the different model sizes? How do I choose the right one?
That's a great question. AMD provides a handy table detailing the maximum recommended DeepSeek R1 distill size for different processors and graphics cards. Smaller distills like QN 1.5B are blazing fast, perfect for a starting point. Larger ones offer superior reasoning but demand more resources. It's all about finding the sweet spot between performance and capability.
So it's a balancing act between speed and accuracy. Makes sense. And what about the steps involved? Is it a long process?
Not really. It's a 10-step process, but each step is pretty simple. You install the driver and LM Studio, then use the LM Studio interface to select your model, confirm the quantization, adjust the GPU offload layers, and load the model. The whole thing is designed to be intuitive. Really user-friendly.
This sounds incredibly promising. The ability to run these powerful models locally, enhancing data security and reducing latency, is a huge advantage. But I'm a little concerned about the memory requirements. Some of those configurations seem pretty demanding.
You're right to be cautious. The documentation emphasizes checking your system's memory requirements to ensure reliable performance. It's crucial to match your hardware to the model size to avoid issues. And remember, using Q4KM quantization helps significantly.
Absolutely, thanks for clarifying that. This has been a really informative discussion. It seems like AMD has made running these advanced reasoning models surprisingly accessible.
My pleasure. It's truly exciting to see how accessible this technology is becoming. Remember to check the official documentation for the most up-to-date information and compatibility details. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating piece from The Guardian. Signature moves. Are we losing the ability to write by hand? It's a really thought-provoking look at the decline of handwriting and what we might be losing in the process. Intriguing, right?
Absolutely. I mean, who hasn't experienced that awkward moment when you have to sign something important and your handwriting looks like a toddler's scribble? But this goes way beyond just bad penmanship, doesn't it?
Exactly. The article starts by discussing auto pens. You know, those machines that replicate signatures. The outrage over Rumsfeld and Dillon using them highlights how much we value the unique, personal touch of a handwritten signature. It's a symbol of authenticity, a connection to the writer.
I see. So it's not just about the signature itself, but the whole process of handwriting? The physical act of writing?
Precisely. The article explores how handwriting offers a glimpse into individuality. Think about analyzing historical documents. The quirks of a person's handwriting reveal so much about their personality and emotional state. Calligraphy, in particular, is highlighted as an art form that celebrates the human element in writing, the variation and responsiveness.
That's beautiful, but the reality is, handwriting is disappearing. The article mentions the removal of cursive from school curricula in many countries. That's a pretty significant shift. What are the consequences?
Yeah, that's a huge point. The article points out that a significant percentage of students struggle with basic handwriting. It's not just about aesthetics. It impacts reading comprehension too. If you can't write in cursive, you can't read it either. And it's not just kids. Adults are losing the skill as well.
It's a bit alarming, isn't it? The article even mentions a pastry instructor whose students couldn't pipe icing because their handwriting was too shaky. That's a practical consequence I hadn't considered. What about the cognitive aspects?
Oh, that's a crucial part. The article cites research showing that handwriting improves learning and information retention. The slower pace forces deeper processing, unlike the speed of typing. It's a more active form of learning. It's not just about the motor skills. It's about cognitive development.
Interesting. So we're losing not only a skill but also a way of learning and processing information. It's a bit like losing a muscle. The more you don't use it, the weaker it gets. The article also talks about the sensory experience of handwriting, the feel of pen on paper.
Yes, that's a really important point. The article emphasizes the tactile and sensory aspects of handwriting, the connection to the physical world. It's a far cry from the abstract nature of typing on a keyboard. It's about the mark of the hand, the unique imprint of the writer.
And the article connects this to a broader loss of embodied skills, right? The decline of handwriting is just one example of a larger trend of de-skilling. It's a loss of connection to the physical world.
Exactly. The article explores this idea beautifully, connecting handwriting to other crafts and the maker movement. It's about the value of handmade objects, the time, effort, and skill that goes into them. It's about appreciating the human touch. It's a fascinating exploration of how technology impacts our relationship with the physical world.
It's a really compelling argument. The article doesn't advocate for abandoning technology, but it urges us to be mindful of what we lose when we embrace efficiency at the expense of human experience. It's a call for balance, for a coexistence of old and new. A thoughtful piece indeed.
Absolutely. It's a reminder that progress shouldn't come at the cost of our humanity, our connection to the physical world, and the unique skills and experiences that make us human. So let's all pick up a pen and reflect on that. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Zig's writer system. It's a bit layered, shall we say.
Layered is an understatement. I was completely lost trying to understand the 3 different types of writers in Zig. Any type, any writer, and generic writer. It's a bit of a head-scratcher.
Exactly. Let's start with writer, any type. It's the simplest, appearing most often in std.fmt. Think of it as a template. The compiler generates a specific version for each writer type used. Zero runtime overhead, but it can bloat binaries and slow compilations, especially with many writer types.
So it's efficient for a few types, but scales poorly? And the documentation a black hole you mentioned?
Precisely. It relies on conventions. You need to check the source code to see which methods write, write-all, write-byte, etc. are actually called. It's not explicitly defined. It's a bit implicit.
Right. And the biggest limitation? It can only be a function parameter. You can't use it in a struct field. That's where std.io.anywriter comes in, right? It's Zig's closest thing to a writer interface.
Yes. AnyWriter is a more structured approach. It's an interface with a write fn and a context. It even implements write-all and write-byte in times based on the write function. But there's a catch. Performance issues can arise because there's no way for an implementation to provide optimized versions of those helper functions.
I see. So it's more structured but potentially less efficient. And then there's std.io generic writer, which I found particularly confusing. It seems to be the actual type returned by file.writer or array_list.writer.
That's the core of the confusion. Generic writer is generic, taking a context and an error type as parameters. This allows for type-safe error handling, unlike AnyWriter, which uses any error, a project-wide error set. This is crucial for reliability, especially in critical systems.
So, generic writer is more type-safe but less flexible because it's not an interface in the traditional sense? It's a generic type, so a generic writer for a file is a different type than a generic writer for an array list.
Exactly. It's not interchangeable like an interface. But for everyday use, you'll usually pass the result of writer to a writer, any type function parameter. It mostly works, but it can be frustrating to figure out the exact requirements for the writer.
So it's a trade-off. Any type is simple but limited and potentially inefficient. Any writer is more structured but can have performance problems. And generic writer is type-safe but not as flexible. It's a complex system.
Indeed. The design aims to balance code bloat and type safety. Generic writer reuses any writer's logic, minimizing code duplication. The @errorcast function handles error type conversion. But, as the article points out, there are ongoing efforts to improve performance and documentation.
It's a fascinating design, even if it's a bit convoluted. Thanks for breaking it down.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating project, Trevor Trainor's Newsstand series. It's a truly unique blend of photography, NFTs, and a dash of nostalgia, wouldn't you say?
Absolutely. The sheer scope is impressive. 17 years of capturing newsstands across the globe, from New York to Tokyo, Paris to Lima. That's dedication. And the evolution from iPhone 4s to 11 Pro Max shots is a nice technical detail.
Exactly. It's not just about the pretty pictures, though they are stunning. The project started in 2012, organically, drawn by the vibrant colors and organized product placement, as Trainor puts it. Each photo acts as a time capsule, the magazine covers and headlines providing an instant snapshot of that moment.
I see. So it's a visual record of a changing world, reflected in the ephemera of newsstands. And then, the unexpected twist, the NFT collection.
Right. 101/1 NFTs, launched in 2022 and sold out quickly. That's a testament to the project's appeal. The physical and digital worlds colliding, you know? Even a pop-up event in LA with a physical newsstand installation and digital screens showcasing the collection.
That's clever marketing. blending the physical and digital aspects so seamlessly. The pre-sale posters, with their 5 different versions, add another layer of intrigue. It's almost like a scavenger hunt.
Yeah, it's a really smart approach. And the press coverage is extensive. Colossal, Boom, Newspaper Club. It's clear the project resonated with a wide audience.
It's interesting how a seemingly simple subject, newsstands, can become such a rich and multifaceted project. I wonder what the limited edition book coming in 2025 will hold.
Oh, I'm sure it will be something special. A culmination of years of work. A physical manifestation of this digital and physical journey. It's a project that transcends simple photography. It's a commentary on time, place, and the evolution of media itself.
Absolutely. It's a compelling narrative, beautifully executed. A great example of how a simple idea, with passion and vision, can become something truly remarkable.
And that's a wrap for today's Tech Bytes and News. Thanks for joining us. We hope you enjoyed this deep dive into Trevor Trainor's Newsstand series. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating paper on 3D scene reconstruction in adverse weather conditions. It's called WeatherGS, and it's pretty exciting stuff. The core idea is to improve 3D Gaussian splatting, or 3DGS, to handle rain and snow.
Right. I've been following the advancements in 3D Gaussian splatting. It's amazing how well it works in ideal conditions, but real-world scenarios, especially with bad weather, throw a wrench in the works. What's the key problem WeatherGS tackles?
Exactly. Standard 3DGS treats weather artifacts, rain, snow, you name it, as part of the scene. This leads to blurry, unclear reconstructions. WeatherGS cleverly separates these artifacts from the actual scene.
Clever! So how does it do that? A sophisticated filter, perhaps?
It's a two-step process. First, an atmospheric effect filter, AEF, removes dense particles like snowflakes and raindrops. Then, a lens effect detector, LED, identifies and masks occlusions caused by precipitation on the camera lens. Think of it as digitally cleaning the camera lens and the air before reconstructing the scene.
Ah, I see. A pre-processing step to clean up the input images before the actual 3D reconstruction. That's elegant. But how does it handle the different types of artifacts? Snow and rain are quite different, right?
You're absolutely right. That's the brilliance of their approach. They explicitly categorize these artifacts, dense particles versus lens occlusions, and tailor the filtering accordingly. The AEF handles the dense stuff, and the LED tackles the lens issues. It's a very nuanced approach.
So after this pre-processing, they use the cleaned images to train the 3D Gaussian model, right?
Precisely. They use the processed images and the generated masks to exclude the occluded areas. This ensures that only the clear parts of the scene contribute to the final 3D reconstruction. It's a very systematic approach.
This sounds incredibly promising. But how do they evaluate the performance? How do we know it actually works better than existing methods?
They created a new benchmark dataset with diverse and challenging weather scenarios. Their experiments show that WeatherGS consistently outperforms state-of-the-art methods in producing high-quality, clean 3D reconstructions across various weather conditions. They even have a project page linked in the paper.
That's impressive. A new benchmark is always a good sign. It shows a commitment to rigorous evaluation. I wonder, though, how computationally expensive this two-step pre-processing is. Could it slow down the overall reconstruction process significantly?
That's a valid point. While the paper doesn't explicitly detail the computational cost, it's a fair concern. The trade-off between improved accuracy and increased processing time is something to consider. Further research might focus on optimizing the AEF and LED for speed, but the results are certainly compelling.
Absolutely. This WeatherGS approach seems like a significant step forward in robust 3D scene reconstruction. It elegantly addresses a major limitation of existing methods. Thanks for breaking it down.
My pleasure. And that's a wrap on WeatherGS for today's Tech Bytes and News. Join us tomorrow for another exciting deep dive into the world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into OpenAI's latest release, O3 Mini. It's a game changer, folks. A real leap forward in cost-effective reasoning.
I'm buzzing. From what I've read, it's significantly faster than its predecessor, O1 Mini, right? And cheaper too?
Absolutely. That's the big news. O3 Mini boasts a 39% reduction in major errors on complex questions compared to O1 Mini. Plus, it's 24% faster, with an average response time of just 7.7 seconds versus O1 Mini's 10.16 seconds.
Wow, that's a substantial improvement. But what about its capabilities? Does it match O1 in terms of overall performance?
That's a great question. With medium reasoning effort, it essentially matches O1's performance in math, coding, and science. Think of it as O1 but streamlined. They even ran it through rigorous tests like AIME and GPQA, and the results were impressive.
So it's not just faster, it's also more accurate? That's incredible. What about the developer features?
Oh yeah, it's packed with them. It supports function calling, structured outputs, and developer messages, making it truly production ready. And it even supports streaming, just like O1 Mini and O1 Preview.
Streaming is key for real-time applications. What about the reasoning effort options?
You can choose between low, medium, and high reasoning effort. This is brilliant. It lets you optimize for speed or accuracy depending on your needs. Need a quick answer? Go low. Tackling a complex problem? Crank it up to high.
That's incredibly flexible. But it doesn't have vision capabilities, right?
Correct. For visual reasoning, you'll still want to use OpenAI 1.03 Mini focuses on its strengths, STEM reasoning.
Makes sense. And what about accessibility? Is it available to everyone?
Yes. ChatGPT Plus, Team, and Pro users have access now, with Enterprise access coming in February. Even free users can try it out by selecting Reason in the message composer. This is the first time a reasoning model has been offered to free users in ChatGPT.
That's amazing. It sounds like OpenAI is really committed to making powerful AI more accessible. What about the safety aspects?
Absolutely. They use deliberative alignment, training the model to reason about safety specifications before answering prompts. They also conducted extensive safety evaluations and red teaming, just like with O1. The O3 Mini system card has all the details.
Good to hear they're taking safety seriously. So overall, O3 Mini seems like a significant upgrade. Faster, more accurate, more accessible. It's a compelling alternative to O1 Mini, especially for STEM tasks.
Precisely. It's a huge step forward in making high-quality AI more accessible and affordable. OpenAI is truly pushing the boundaries of cost-effective intelligence. And remember, they've reduced per-token pricing by 95% since launching GPT-4.
Incredible progress. This is definitely a release to watch. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into HD Hyundai's groundbreaking new hydrogen-powered excavator, the HW155H. It's a massive leap forward, wouldn't you say?
Absolutely. A 14-ton wheeled excavator running on hydrogen? That's incredibly impressive. I'm particularly interested in the operational aspects. How long can it run on a single tank?
Yeah, the endurance is pretty amazing. They're claiming between 7 and 8 hours of continuous operation on a single 20-minute refill. That's a significant improvement over traditional ICE-powered excavators, especially considering the zero emissions.
7 to 8 hours is remarkable. That's a full workday for most construction sites. But the article mentions a resurgence in wheeled excavators. What's driving that trend?
Good question. Wheeled excavators are becoming increasingly popular because of their versatility. They're easy to deploy in urban areas, navigate tight spaces, and can be equipped with various attachments for different tasks, from digging to demolition. Plus, municipalities are pushing for greener solutions, and these machines fit the bill perfectly.
I see. Interesting. So this hydrogen model directly addresses the environmental concerns. But the article also suggests that battery electric versions might be more practical in the long run. What's their reasoning?
That's a valid point. The article argues that while hydrogen is a great solution for this specific application, it's unlikely to become a mainstream alternative to battery power for general transportation. The infrastructure for hydrogen refueling is still limited, and the energy density isn't as high as batteries.
Right, the refueling infrastructure is a huge hurdle. But for specialized equipment like this excavator, where the operational needs are different, hydrogen might be a more suitable solution. It's a niche application, but a very important one.
Exactly. And HD Hyundai's commitment to hydrogen is noteworthy, especially given South Korea's national focus on hydrogen technology. They've already integrated it into semi-trucks, forklifts, and even military vehicles. This excavator is just another step in that direction.
It's also worth noting that this excavator won a platinum prize at the 2024 LACP Inspire Awards. Tusk. That's a significant validation of its design and the company's commitment to ESG. It's not just about the technology, it's about the broader environmental impact.
Absolutely. The award underscores HD Hyundai's dedication to sustainable practices and reinforces the importance of this development within the construction industry. It's a win-win. Reduced emissions and a technologically advanced machine. This HW155H is a game changer, a testament to innovation in the construction sector.
It certainly is. And the fact that it's already generating so much buzz before its official debut at Bauma 2025 speaks volumes about its potential. Thanks for breaking down this exciting development for us.
My pleasure. And to our listeners, thank you for tuning in to Tech Bytes and News. We hope you enjoyed this deep dive into the world of hydrogen-powered construction equipment. Until next time, goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into setting up a local AI inference rig using DeepSeek R1671B on a budget-friendly EPYC server. It's a powerful setup, folks.
Awesome. I've been wanting to run large language models locally, but the cost always seemed prohibitive. What makes this setup so cost-effective?
The key is leveraging the power of a well-chosen AMD EPYC ROM system. The author used a system that's already proven itself, achieving 3.5 to 4.25 tokens per second on the full 671B model. That's amazing performance for the price.
Wow, that's impressive. But isn't running the full model resource-intensive? I thought you needed a ton of GPU VRAM.
You're right, it usually is. But this setup focuses on CPU-based inference. While a massive GPU rig would be ideal, this approach is surprisingly effective and allows for concurrent running of smaller models, like vision models, simultaneously. It's all about efficient resource allocation.
Interesting. So what are the key hardware components, and how much did it all cost?
The core is a 64-core AMD EPYC processor. Either the 7702, 7V13, or 7C13. The motherboard is a Gigabyte MZ32AR0, which supports up to 1 TB of RAM. They also recommend a robust cooling system. The total cost? Around $2,000, potentially reaching $2,500, depending on the CPU and RAM choices. It's a fantastic value proposition for the performance you get.
Okay, that's a reasonable price point. But the software setup seems complex. What's involved?
It's definitely not a walk in the park, but it's manageable. The author recommends installing Ubuntu 24.04 on bare metal for optimal performance. Then, it's a matter of setting up the BMC, baseboard management controller, on the motherboard, configuring a static IP address, and installing Ollama, a model management tool. After that, you pull down the DeepSeek 671B model, which is a hefty 400 gigabytes.
400 gigabytes. That's a lot of storage. And what about OpenWeb UI?
Yes, it is. OpenWeb UI is used for the user interface. It's installed via Docker, which simplifies the process. Then, you connect OpenWeb UI to Ollama. Configure advanced parameters like context length and number of threads, and you're ready to run DeepSeek. It's a multi-step process, but the author provides detailed instructions.
I see. The author mentions several BIOS settings to optimize performance. Are those crucial?
Absolutely. They're essential for squeezing out the best performance from the EPYC processor. Things like disabling SMT, simultaneous multithreading, and adjusting the CTDP, configurable TDP, are key. The author provides specific values for the 7702, but you'll need to adjust them based on your chosen CPU. It's a bit of a technical deep dive, but it's worth it for the performance gains.
Got it. So in summary, this guide provides a comprehensive walkthrough for setting up a powerful, yet affordable, local AI inference rig. It's technically challenging, but the results seem worth the effort. What are your final thoughts?
I agree. It's a fantastic guide for those who are comfortable with server administration and want to run large language models locally without breaking the bank. The author's attention to detail and clear instructions make this a valuable resource for the community. It's a testament to the power of open source tools and community collaboration. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.